then it will be class practice. Okay, so yesterday we looked at differentiation of trigo functions already. I have went through with you about how sine, cosine and tangent are being differentiated. So for sine x it becomes cosine x. For cosine x it becomes negative sine x. While for tangent x it becomes secant square x. Okay. Then yesterday I have also shared with you, okay, when we have sine, cosine and tangent, instead of having x inside there, okay, what if I have axb, okay, or for example 3x minus 7 or 2x squared minus 3, okay, then what do we have to do? We have to actually differentiate the insides of it as well, okay. So another consideration that we have to make would be, for example, in try 3, where we want to differentiate all come in please. Okay, we want to learn how to differentiate functions that look like this. Right? So let's just begin with the slightly simpler one, cosine x, cosine to the power of 3x. Okay. We need to recognize that cosine cube x is as good as writing it as cosine x to the power of 3. So with the idea of chain rule, okay, that we had developed using algebra, we can bring down the power, then power minus 1. So that is cosine square x. Then we differentiate inside, okay, which is actually cosine x differentiate, then we will get negative sine x. So if I were to go through the very strict working, okay, so bring down the power, I will get cosine x square. Differentiate the insides of the brackets, I get negative sine x. But we know that cosine x bracket square is as good as writing 3 cosine square x. Since there's a negative sign there, I bring it out to the front. Therefore, the differentiation of cosine cube x is negative 3 sine square x sine x. Okay? Right, so it's always bring down power, differentiate inside, okay, everything that's inside. Alright? Then next we look at part B. Oops, sorry. Where did that come from? Okay, tangent x minus 3 to the power of 4. Okay, so in this case, do keep in mind, for this one you cannot like bring in the power, okay, because this is tangent x minus 3 multiplied by itself for 4 times. Okay, so we bring down the power in our differentiation. So 4 times tangent x minus 3 to the power of 3. Differentiate the insides of the brackets, tangent becomes secant square x. Minus 3 becomes nothing. So we have 4 secant square x, tangent x minus 3 to the power of 3. Okay. And then the very last one, we have y equals to square root 1 minus sine x plus pi. That is as good as writing 1 minus sine x plus pi. to the power of half. So our chain rule will say bring down the power minus 1. Differentiate the insides of the bracket. So differentiate 1 becomes 0. Then we differentiate negative sign. So sine will become cosine. Therefore, this is negative cosine x plus pi. Okay. So we're done with the outer parts of this bracket here. Then we need to still go in deeper to look at sine x plus pi itself. So x plus pi differentiation is 1. Okay, so let me just write it out that this is the differentiation of 1 minus sine x plus pi. This is the differentiation of x plus pi. Okay, so we're going deeper and deeper inside the bracket, inside the function itself. Okay, then we simplify and we would get negative half cosine negative half, so cosine x plus pi over 2. This one, because it goes to the denominator, so I will have 2 square root 1 minus sine x plus pi in the denominator. Okay, do take a closer look and try to understand the working here. Okay, if you don't understand the algebraic manipulation, please let me know. Understand? Yes. Is it the what? Differentiate x plus pi is 1. Yeah, come in. Differentiate x, 1x now. Okay. Any questions? Alright. Those who just joined, do take a look at what we have here regarding tri-tree. Okay. If you need me to explain, maybe you could actually gather together first. Then the rest of you, okay, please work on these questions. Be prepared, it's a lot. You need to get it ingrained into your brain. Okay? I'm sure this will take out the whole lesson already. Sorry? Do it in notebook lah. It's not homework. Okay? Do it in your notebook. Oh, you have not seen the homework yet. Yeah. This kind of things need to practice.